So this part of the lesson is my absolute favorite part. I love using factor trees to find the prime factorization of numbers. And so we are going to start out, I think, with the number 48 and practice using 48 and making a factor tree to find its prime factorization. So we're going to start out by making two little lines that come off of 48, and we're going to think of any two numbers that we can, any factors of 48 that will multiply together to make 48. I think today I am going to start with 4 times 12. Here's how you have to think about a factor tree. Anytime you get a factor listed that is a prime number, again, meaning that it has exactly two factors, the number 1 and itself, you have to circle the number because it becomes fruit. If you think about this in comparison with a regular tree, do you ever see a branch growing out of fruit? You don't, because it's not possible. The fruit grows off the branches. And once you have a piece of fruit, you have the end of a branch, or in this case, a prime number. 4 and 12 are not prime numbers. Neither one of them are. So we're going to continue factoring until we find a prime number. I'm going to now think about two numbers that multiply together to make 4. Pretty easy. 2 times 2. And I know from past experience working with prime numbers in this unit that 2 is a prime number. So I'm going to go ahead and circle my fruit. Now I can't have any more branches growing out of that one, so I'm totally done with those numbers. Next, I'm going to continue factoring the number 12 because 12 is not a prime number. It has way more factors than just 2. So I'm going to think of two numbers that multiply together to make 12, and in this case, I'm going to use the numbers 2 and 6. Again, I know that 2 is a prime number, so I'm going to circle that fruit and stop using that number. 6, however, is not a prime number. It is a composite number, so we are going to continue factoring that number until we get some primes. Two numbers off the top of my head besides 1 and 6 that multiply together to make 6 are 2 and 3. Again, I know 2 is a prime number, always is, so I'm going to go ahead and circle that fruit. And as we talked about a couple of slides ago, 3 is also a prime number because it has exactly two factors. Now this is the first step to a prime factorization. This is not your answer, this is just your work. So the answer to this, the prime factorization of 48, is 2, for that one, times 2, times 2, times 2, times 3, and that's it. So I have listed all 4 of the 2's that I came to. Here's 1, 2, 3, 4, and then 1, 2, 3, 4, and my 3, and it's listed as a product. So we're listing the number sentence that expresses this as a product in the end. This is the prime factorization of 48. Alright, so I'm going to walk you through this one more time using one more number, just so you have another comparison for how to do this. This time I'm going to use the number 64. I know that 8 times 8 equals 64, so I'm going to start off using 8 times 8 as my two factors. And since I know that 8 is an even number, I know that I need to keep factoring. They're not fruit yet. I have 2 times 4. 2 is prime, and 4 factors down to 2 times 2, also fruit. Then I'm going to do the same thing on this side, which will give me the exact same numbers. I'm going to have 2 and 4. 4 is not prime, so I'm going to factor that down to 2 times 2. And I end up with a total of 1, 2, 3, 4, 5, 6 2's. So the prime factorization for 64 is 2 times 2 times 2 times 2 times 2 times 2. And that equals 64. Alright, I hope you're ready because here is your practice problem for the day. I would like for you to try and find the prime factorization for the number 27. Don't forget to draw in your little arms of your trees and circle your fruit as you go. Fruit is a prime number, and once again, prime numbers are any number that has exactly two factors, 1 and itself.